All right, the next ones are our special angles that we have. When we were talking about the radian measures, we were either talking about 30, 60, 90-degree angles or 45, 45, 90-degree angles. So when we looked at our unit circle and we were plotting them in radians, one of these triangles is going to become our reference triangle on our circle. So for 30, 60, 90, the side opposite the 30 is going to have a length of 1. The hypotenuse will have a length of 2. Using the Pythagorean theorem, you could figure out that the side opposite the 60 is going to be square root of 3. So those are always the standard that we use for a 30, 60, 90. Opposite the 30 is 1, opposite the hypotenuse is 2, and opposite the 60 is square root of 3. When we have a 45, 45, 90 triangle, the sides opposite the 45s will each be 1. That makes the length of the hypotenuse the square root of 2. A squared plus b squared equals c squared. So the ones opposite the 45s will always give up 1 unit, and that makes the hypotenuse square root of 2. So when we are looking for the points, we're thinking about where is that angle in our circle. 5 pi over 3 is over here, with this being a 60-degree angle, so that one's a 30-degree angle. So the side opposite the 30 would be 1. The side opposite the hypotenuse would be 2. The side opposite the 60 is normally the square root of 3, but notice it's going down, so it's negative square root of 3. So when I'm giving the coordinates, what I'm doing is I'm giving the x-coordinate is the cosine, the y-coordinate is the sine, and I'm putting it in as an ordered pair. Cosine is adjacent over hypotenuse, and the sine is the opposite over the hypotenuse. So when I look at this one, the adjacent is 1, the hypotenuse is 2, so my cosine is going to be 1/2. My opposite is going to be negative square root of 3. My hypotenuse is 2, so negative square root of 3 over 2. And so my terminal point on my unit circle then would be at 1/2 and negative 3 square root of 2. If I'm doing 3 pi over 4, then I'm talking about a 45, 45, 90 triangle. 1 pi over 4, 2 pi over 4, 3 pi over 4. So there's my reference triangle. My reference triangle always goes down to the x-axis. So we've got a 45, 45, 90. So 1, 1, and the square root of 2. However, this is going backwards, so that one's going to be negative 1. So cosine, my adjacent over my hypotenuse. Well, if I have to do my adjacent over my hypotenuse, I'm going to get 1 over the square root of 2, and of course I'd want to rationalize that denominator by multiplying by the square root of 2 over the square root of 2. So I get negative square root of 2 over the square root of 4, which is just a plain 2. My sine, going to be similar to that, but it's going to be a positive 1 over the square root of 2. And if I have 1 over the square root of 2, again, I have to rationalize that, so I get a positive square root of 2 over 2. So number 9, we want to find 4 pi over 3. We're going to change it into pi over 6. So I'm going to do 8 pi over 6. So 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6, 6 pi over 6, 7 pi over 6, 8 pi over 6. So my reference triangle is going to be down here in quadrant 3. I'm going to redraw it. With this being the 60-degree angle, so that one's 30. So I would have 1, 2, and the square root of 3, but this is going backwards, so it's negative. This is going down, so it's negative. And so my cosine would be the adjacent over the hypotenuse, negative 1 over 2, My sine would be the opposite over the hypotenuse, so negative square root of 3 over 2. Now I did those all by drawing my reference triangles and knowing all those things about sine and cosine. On Alex, for right now, they're going to have the information kind of drawn out for you on a table. So if I go over to Linda's note sheets, over here. On the Alex program, they're going to have these nice little tables for you. So if you look at the first one was 5 pi over 3. So I want to use the ones that are multiples of pi over 6. 5 pi over 3 you can see is way over here. You can see the answer, 1/2 and negative 3 pi over 2. The second one that we did was 3 pi over 4. 3 pi over 4 was right here. You can see that they got negative square root of 2 over 2 and positive square root of 2 over 2. And then the last one was 4 pi over 3. So 4 pi over 3 you can see is right down here, negative 1/2 and negative square root of 3 over 2. So you'll be able to either look at Linda's note sheets, or if you print and explain from Alex, they might have these separately, one for the multiples of pi over 4 and the other one's for the pi over 6, the 30, 60, 90s. So you might want to just print out my note sheets, but try drawing your reference triangles and then double check by looking at their chart to see if you're getting the same answers, so that you get used to the reference triangles, and that the 45, 45, 90 is 1, 1 square root of 2, and that the 30, 60, 90 is 1, 2 is the hypotenuse and the square root of 3, and then doing the sine and or the cosine for the x value and the sine for your y value. And so for right now on Alex, they're just going to give you the chart so that you can kind of look at it, but you want to get used to your reference triangles.